So in this question here, we're going to find the area which confines these two inequalities. Y is greater than or equal to x squared minus 2, and at the same time y is less than or equal to 9 minus x squared. Now I've drawn these two graphs together, so this here outlines the area that we are trying to find. So these bits here, so inside this. Okay, so how do we go about finding that? Well, there's more than one way of doing these things, always. Now, the first method I'm going to show you is, first of all, I'm going to find the area under this curve here. Y equals 9 minus x squared. So the whole curve, not just this bit, but including these two bits. So let's do that. So before we can do that, we need to find the intersection points here. So hence we need to solve y equals 9 minus x squared. So if y equals 9 minus x squared, we want to find out where it crosses the x-axis, so set it to 0. So 0 equals 9 minus x squared, and then we get x squared equals 9. So then we take the square root, x equals plus or minus 3. So therefore the x coordinates here are going to be 3. So this one here will be 3 comma 0. This one here will be minus 3 comma 0. So now we can integrate and find the area under all of this from minus 3 to 3. So let's do that integral. So parameters minus 3 to 3. We've got 9 minus x squared. And integrate with regards to x. Okay, so integrate 9. We will get 9x and minus the integral of x squared, so we've got minus x cubed, let's just make that an x cubed, that's an x, over 3, and then evaluated at minus 3 and 3. Okay, so first of all let's plug in 3, so we get 27 minus 3 cubed is also 27, divided by 3 gives me 9. So that's the value at 3, and then we subtract the value at minus 3. So then minus 3 plugged in for x, we get minus 27. And then minus 3 cubed, that gives me minus 27, over 3 gives me minus 9. So we've got minus minus 9. So if I write minus minus 9, and then what do we get simplified? I've got 18 minus 27 minus minus 9 gives me minus 18. So 18 minus minus 18 gives me 18 plus 18. So that gives me 36. So the whole area inside the main part is 36. So that's the first solution that I need. The next bit, if I subtract the area here from this, that will then give me this part here. So that will give me my solutions there. So now what I need is these intersection points here. So therefore I need to solve the graph y equals x squared minus 2 when it crosses the x-axis. So let's first of all solve that. So let's put a line there. Y equals x squared minus 2. So if I set it to 0, obviously we want it when it crosses the x-axis. I've got 0 equals x squared minus 2. So then I've got x squared equals 2. Take the square root on both sides. I'll have plus or minus root 2. Okay, so now that's going to be those points there. So I've got square root of 2 comma 0, and this one minus root 2 comma 0. Okay, now just to do under this curve, it's only going to get me as far as this intersection point here. So there we'll come down to another point there. Okay, so if I can find the area underneath this curve here and underneath this curve here, and then multiply them both by 2, that will get me to my solution. So first of all I need to find out where these two graphs intercept. So let's set them equal to each other. So let's just pour a line down there. Let's put a line down there. Let's do the integral, do the equality in the middle. So I've got x squared minus 2 equals 9 minus x squared. So we need to solve for x to find the x coordinates. We don't need to worry about the y coordinates because we're not interested in that. We just need the x coordinates. So add x squared to both sides. I've got 2x squared. Now I've got 9 here. So I've got minus 2 here. Get this minus 2 across. I'll set it equal to 11. And then x squared equals 11 over 2. So take the square root as we did before. X equals plus or minus square root of 11 over 2, or 5.5. You can put whichever you like. So that's the points of intersection of the two curves. So that one there, if I come down here, that will be root 11 over 2 comma 0. And this one will be minus root 11 over 2 comma 0. So now let's find this first bit. So let's go inside here. So let's find that one and find that one. Now, as parabolas are symmetrical, these two will have equal area. So if I just find the area, let's say with these points, and then just double it. So let's go with this one first. So what I need now is the integral from square root of 2 to square root of 11 over 2. And what I need now, my formula for this curve is x squared minus 2. So if I integrate over that, that will get me to my answer. Okay, let's integrate x squared minus 2. So the integral of that is going to be x cubed over 3 minus 2x. Okay, right. Now my parameters are root 2, root 11 over 2. So, okay, root 11 over 2. Okay, right, let's plug those in. Let's see what happens. So when I've got square root of 11 over 2 cubed, so I've got 11 over 2 cubed, but I've got the square root of that. So I can put them inside each other, that'd be fine. That will get me to my result. And then I've got over 3. And then subtract 2 times square root of 11 over 2. So that's my upper bound calculated. Now I need to plug in square root of 2. Well, square root of 2 cubed is going to give me 2 times square root of 2. So I've got 2 root 2 over 3 minus 2 root 2. Okay, so that's going to give me approximately 1.49. But remember, we need that area twice. So I need to double that. So that's going to give me approximately 2.99. So approximately 2.99 when it's been doubled. So if I can put the 2 in there now, if I put that there, and I multiply everything by 2 all the way along, that'll give me 2.99. So that takes care of that part. Now we need to have a look at this part. So let's put my lines going downwards. Let's find the area there. Again, we need integration. So I need to go from this point to this point. So I need from root 11 over 2 to 3. So I find the area of that, double it, because again, parabolas are symmetrical, so they will have equal area. So let's do that integral. So my lower bound, square root of 11 over 2. And my upper bound is 3. Okay, right. Let's find the integral of that, and when we get to the end, we'll double it again as we did here. So what's the equation for this curve? It's 9 minus x squared. Now we've already integrated this curve here, but obviously with different bounds. So 9 minus x squared dx, we know the integral of that is 9x minus x cubed over 3. So now let's work along here. I've got 9x minus x cubed over 3. This time our parameters are 3 and square root of 11 over 2. Okay, let's plug in 3 inside here. So let's work along. 3 9s are 27. So I've got 27 minus x cubed, that's 3 cubed, that's 27 over 3, that's going to give me 9. Okay, so that's the first part at 3. So pretty much the same as what we did here. But now the lower bound changes. So now subtract when we've got square root of 11 over 2. So 9 times root 11 over 2. That's all inside the radical. And then minus this cubed. So let's write that. So minus 11 over 2 cubed, put inside the square root, divided by 3. So that takes care of that. Okay, right, let's plug that into a calculator and we get just under 1.2. We get 1.19 something, something, something. But then we've got to double it. So again, let's put the 2's in front of all these calculations. And we get approximately 2.39. Okay, so that's that integral. So that's it for the integration. Now we just need to work out the final answer. So we got the area of the main bit, that was 36. So that was there. So that's an approximation because I've rounded it off. That one, that one, that one. So we've got 36 for the main part. So area equals 36 minus 2.99. So that's for this bit, 2.99. And minus another bit, which is this bit here, which is 2.39. So, and eventually we'll get to 30.62 approximately. So approximately 30.62. That is my final answer for that area inside here. So that is 30.62. Okay.